Welcome back to the stream. We're live in all the usual places. Got the bits flowing out to Diode Zone, Twitch, and YouTube. I don't know if I'm in a very talkative mood, so maybe we'll just do more of a quiet programming stream. I think I'm gonna dig into the juce C++ code here. I was yammering on about design decisions on the last stream, and I had some time to read code and think about what I want to do and actually plan out the design a little bit in between streams. So I might just be able to write some stuff. I could go on and on about different component choices and using parts that are from juice versus the standard C library versus other libraries, but I don't know how much I even feel like talking about that. We might just dig in. I think right now it's just me. Tuco's in the other room eating. Oh, right on cue, actually. Are you digesting, boy? Hey. Oh yeah, back to that chair. Oh, got some nice evening coffee. How's that, Took? Oh, what a poor beast. Can we get him in focus? Just getting all hung up on how to define the window parameters for windowing the grain data and how to store those in a way that it has a good kind of level of granularity for hashing. In between streams, I came up with the obvious in hindsight answer, which is to just represent the window lengths in number of samples after converting everything. I guess that's what got me thinking about sampling some more, and I had been assuming that I just have a single just like a single shared resampler at the, like right before the output of my plugin. So the data sets, this granular synthesizer I'm working on loads, they tend to be relatively low sample rate, partially because they're huge data sets and efficiency is important, but partially because they're voice or speech or like simulated speech. So they tend to be fairly low frequency anyway, so they don't generally need very high frequency. So, you know, of course the code, I've been trying to keep it as general as is convenient, but most of the data I'm actually processing is at 24 kilohertz. And so I've been trying to ensure that this handles resampling in a efficient and high quality way, even if I'm playing just massive amounts of randomly accessed grain data. The approach that I was adopting is I grabbed the highest quality resampler that Juice provides, which is a not super efficient looking, but probably okay windowed sync resampler, and that seemed fine. Just have one of those, stick it at the output. But then I start thinking about, well, what's the design space of stuff I can tweak about these audio signals, like on a per grain basis that might benefit from the extra sample rate, or from stereo. Because like also the input's mono, but maybe I want this plugin to generate stereo because maybe it has stereo effects that get applied on a per grain basis. Oh yeah, the load graphs. The CPU's been maxed out for a little while. I've been running these audio analysis batch jobs on it. Actually, I just had a big batch job that was close to finished and it crashed because I ran out of swap space. Oh, Tuco. Oh. I'm glad he and I are on the same page. He was mad at me for a minute because I ran out of his favorite food, and it was going to be like a day or two longer than I expected to actually get the food in, and so I was hoping I could feed him with one of the many other kinds of foods that I know he's liked in the past, which I still have, and they're still, you know, within their freshness dates or whatever. But he's not having any of it. He's very picky about food, even post-dental surgery. But as long as I have the food that he likes, he'll eat plenty of it, so he certainly put on some weight, which is good for him. He's a big fuzzo. And he's quite happy to just sit there and hang out and purr, and he's been cuddling up next to me in bed more often and generally hanging out in a way that is still pretty intense, but at least like chill by his standards. This is where I have a problem with my split keyboard. Because if I've got one hand petting Tuco, then I can't do basic window management operations on my keyboard. I can drink coffee. I've got some Rust code on this other screen. I was getting so frustrated at Juice, the C++ framework I'm using, and then by extension kind of frustrated at C++ in general. C++, to be fair, has gotten so much better over the past 10 years or so. I think I'm mostly going to be using C++ 11 and C++ 17 features to make the concurrency in this not terrible. So there's that at least. Juice has its own libraries for doing things like threads and mutexes, and has its own containers. I'm assuming a lot of that's a vestige from when STL didn't have... I mean, I don't know, it's been a while since you couldn't rely on stuff like standard vector to be available in all the compilers, so I figure the stuff like juice array must just be there either for the most basic convenience or because they designed it like before even the STL in general was widely stable. Because like in the early 2000s, you couldn't really rely on compilers to support the STL just in general. It was much more portable to limit yourself to C, but that changed pretty quickly, so I don't know. Oh, there's a question about how I keep up with the new stuff in C++. I mean, I don't really, so like it's not currently something that I get paid to do. So I don't spend a lot of time on it, but if I see a new feature in somebody's code that I haven't seen before, I'll generally try to look it up and see what's going on. I guess the most recent thing that happened with was the new brace initializers, which I think were in C++ 17. So C and C++ have had different strategies for initializing objects, and they added a new one, which, if I understand it right, it's a way to initialize objects in, gosh, what is even the right terminology for this? It's an initializer you can use even in like static contexts, like in like defining default values for class members and things like that, that has the same syntax as invoking the constructor, if I understand it correctly. It basically does what you would expect an initializer to do, but it's like the first time that's actually been the case in C and C++. You know, C focused much more on just doing the thing that matched the CPU's semantics fairly closely when it was first introduced, and then evolved from there. And then C++ evolved in some similar but also some different ways. Last time I did like a relatively deep dive into new features in C was probably, or in C++ was probably around C++ 11, which was when I think auto came along, which was a pretty big change. And Juice has a lot of that in it. Like you look at Juice and it's got a lot of modern C++, and they encourage people to use auto in the examples. They're using the STL threading in the internal implementation for a lot of the Juice threading now. I haven't gone back in the version control history, but I'm assuming that that stuff in Juice predates the stuff that STL now has, and that it might have originally been stuff that they implemented separately for each platform, and now it just mostly is a wrapper around the STL. So I don't know, trying to figure out what's good, what isn't. I guess this Rust stuff came up because I was particularly offended by the way Juice implements its thread pool. I guess I'm in a slightly more talkative mood than I expected. I hope that's okay. I can also maybe shut up and code. So yeah, I guess the context for this is I'm trying to do a granular synthesizer that has the gimmick of using large data sets of pre-sorted and kind of pre-identified features in the audio. So you can run this, the thing that's currently burning out my CPU right now, you can run that or something equivalent, and it'll chew through a bunch of input audio files. It'll identify pitches and like how much of a kind of pure tone versus how much noise that frame of audio is. And it'll filter those, and it'll save a database of potential grains that include those kind of highly voiced sections of audio, according to whatever thresholds you set. And then it writes this intermediate file that has just the audio data itself and those sorted or those identified grains. And then I process them a bit more into these compressed archives that I'm intending to be able to access rapidly for real-time synthesis. It's kind of a multi-step thing so that you can run the slow step once and then tune the parameters multiple times if you want while you're running the kind of post-processing tool. Oh, Tuko, are you sitting right in the good spot for this to work? You're so helpful. Got cat hair all up in my allergy receptors now. Yeah, so the assumption here is that the data set's going to be bigger than you want to fit into memory. You don't want to have to wait for the whole thing to load in memory, even if it does fit into RAM, but I also want it to be able to work with stuff that's like hundreds of gigabytes as long as you have a fast SSD. And I went through this in more detail on the last stream, but like Juice already has a way to load audio from disk in the background on a thread stored in a buffer. It has an algorithm that breaks down really quickly if you want to store any sizable amount of audio, or if you have a lot of discontiguous blocks of audio, both of which are my situation. So then I'm just like, okay, what if I just want to implement this myself? I want a thread pool. I've already got actually two background threads in this audio plugin. I've got one that I'm using to render, I've got one that I'm using to render the map that goes in the UI, and then one that I'm using to load index data, which is like almost a silly thing to have a separate thread for, but I don't know that I want to have to wait for, I don't know that it's really worth like starting and stopping a thread when I'm loading or when I'm not loading. So I might just have like one thread that sits around idle most of the time. But if I'm loading a completely different, database of sample data, it'll wake up and read, I don't know, like 100 megabytes of data into RAM and then go back to sleep. It's the kind of thing that I would totally delegate to a generic shared thread pool, but I don't really know that there's a good spot for such a thing. There's no notion of a process-wide thread pool in the environment we're running in, because this might be like embedded in some other application. Like it wouldn't make sense for Juice to provide something like that by default. So you could start a thread pool in the audio processor, which is the kind of highest level thing that we have in our application that's shared between all the different environments that this might run in. So I might make a shared thread pool that's just for things like UI rendering jobs and like index loading jobs, because I think the Juice thread pool might be a good match for stuff like that doesn't need much performance. I think I just talked myself into using a thread pool for that instead of a couple of separate like one-off threads. Oh gosh. Sorry. So anyway, I'm getting a little ahead of myself and thinking that maybe I want 2 thread pools instead of 0 thread pools. Or possibly 1 thread pool and then 1 custom thread pool. So if I were to just use Juice's data type for all of this in a straightforward way, I could have a thread pool job for loading each, for preparing the audio waveform data for each grain. So I was talking about this part of the design on the last stream, but I think I can identify like a packet of characteristics that I would want to be transformed into one chunk of audio data. So it would be stuff like the grain number in the index, the window parameters for that grain. Wasn't there something else? This isn't my code, so we could look at that once we're actually back on the other file. Anyway, there's some characteristics like that. It's mostly the window parameters and the grain number. Oh, that's right. I was thinking about including a resampling parameter in there, since I was talking about resampling earlier and I didn't quite get to the point. My prototype is currently using a single shared resampler, but I think if I have all these background threads that are loading and windowing and like amplitude normalizing all of these grains, that's probably a decent place to oh gosh, So anyway, yeah, if I'm already doing all this work per grain, I'm just thinking maybe there are some reasons it would be great to do sample rate conversion per grain. I mean, obviously then I could change the pitch of individual grains, which would probably, like, it's not really the sound that I want to investigate first, but it's like a relatively obvious thing to play with a synthesizer like this. And if you're resampling anyway, then there's no reason not to. So the other thing I was thinking of, though, is that if the grains are getting really small, then it might be worth the, I guess, latency compensation I could introduce, like if I'm resampling everything. I don't know that that really matters, since I think the latency is pretty similar whether I don't know how much I care about the time accuracy of the MIDI events coming in at this point. I think I might have some design decisions related to that I can just put off. But, you know, the higher quality resamplers introduce a lot of delay. If I'm sticking that on the output path, I'm stuck with that delay no matter what. Whereas if that's prior to the grain data cache, then there might be opportunities for compensating for the latency. Someone's asking if there's multiple mics. Yes, there's multiple mics. I can, they're pretty close together, which is why you're hearing it now. So I guess I'll just turn one of them off. I don't know where he's going now. All right. Oh, he's going to eat more. Oh, here's where I had the thread pool open. So far this looks fine. It's like a basic thread pool API. Yeah, there's a couple of different ways you can add a job even. There's a class that you can instance. You know, you can make an instance of your own subclass of this. Or you can pass it one of these STL functions. oh, and then here's where we go off the rails. Like already it's suspicious, right? Like what are they doing with an array here? Are they, and you hope that they're implementing maybe their own double-ended queue. So where's the head and tail pointers? But there's no head or tail pointers. All right, so it's got a few problems here if I wanted to use this for, like, for something that this would be fine for, if you had a bunch of, like, UI thumbnails to load in the background, if you had, samples you want to load in the background, stuff like that. If you're loading, like, a couple of dozen user-visible objects, this will be fine. If you're loading hundreds of things every audio frame continuously on all the cores, I don't think this is going to cut it, which is kind of more of where I'm trying to go with the synthesizer. All right, so like for one, the data structure we're using is just an array with a mutex over the array, which is not that bad, except we have operations like this where we're moving everything in the array, and this ends up copying all the pointers in that list. Basically, it makes a bunch of the operations here order of n squared on the number of jobs. So as you increase the number of jobs, you end up with n squared operations on that list instead of just n operations, because you keep rewriting it and for every item moving all of the existing items. So there are a few cases like this where we're just moving, but like I think this is the main one here. So every time we run a job, we take this lock and then copy the whole job list. Yeah, and then the other thing I was worried about with this is every time we wake up one of the worker threads, we're actually waking up all the worker threads. So add job. A better implementation of this might have a wait queue with just workers that are available, and it wakes up one available worker. Instead of waking up one available worker, we're waking up all the workers. So they're all just going to rush and hit that same mutex and trying to access that data structure at the same time. So, one will get through, the rest will go to sleep. It's not a correctness problem. It's just not great for performance. Oh, is the slight echo better? This just had me nostalgic for the better multi-threading support in Rust's standard library and a bunch of the common Rust crates, and just generally how much easier it is to reuse code in Rust. I mean, there are plenty of systems for importing libraries and modules in C++. It's almost that the problem is there are so many systems, whereas a lot of languages have like a built-in package manager. C++ came about before that was really a requirement people had. So it's a bit more of a mess to just try to do anything with dependencies in C++. So there's a lot of incentive to just keep things simple and use just stuff that's in the standard library and stuff that's bundled in juice if possible. So even though there are a bunch of libraries that we are not Boost, did I say Boost? There are libraries like Boost we could use, but juice is one that we're already using, and it's beneficial to avoid expanding the set of dependencies right away, I think. Anyway, so that just had me thinking, well, what if we just throw the whole thing out and rewrite it in Rust? And then there was this project I found that is kind of a proof of concept for a VST2 plugin written in Rust. It's almost something I would consider using as inspiration. Like, my main concern is that I do actually want this to run in environments other than VST2. There's a plugin host I like that's VST3 only. Some people like audio units. I find it convenient to be able to run things standalone, which Jack is pretty good at. So yeah, this does actually work. I don't think I demoed this on last stream, did I? It's pretty basic though. Like, you can use whatever Rust-based GUI toolkit you want. The example they have here just uses some kind of low-level GPU wrapper. I don't need to have the close-up of Tuco's junk right now. Yeah, so this is in Rust. That's what I was looking for. Yeah, anyway, it's tempting to just switch to something like that, but I think really I am going to stick with Juice for a lot of the audio related stuff, but also just try to maybe tread lightly on the concurrency parts of Juice and use the STL directly whenever possible. I mean, beans. I mean, I was also hoping to get the green screen back in there. Maybe a good first step to bite off here would be to replace the couple of time slice threads I have with one of the juice thread pools. It's basically an independent task from creating the like the high performance thread pool for the grain data loader, but this will kind of clean up the space a little bit for that. I think I'm kind of misusing time slice thread here. Like it's really designed for short-lived tasks. And I'm kind of using it for something where it was a toss-up between using Juice's time slice thread and just using a single purpose thread. But yeah, I don't know. I think if I have a very small shared thread pool with just like one or two threads in it to use for the UI and for index loading, that might be the best approach. I'm just allergic to everything now. Maybe we can adjust the cat cam. Sorry. I had second thoughts about adding additional files here. Well, it does still compile. Yeah, so this is what it currently looks like. The background threads that I am about to replace are used for generating this image here. And we're actually loading the file. So while it's in that loading grain index state, that's running on a background thread. I was kind of thrown off just like understanding the scope of Juice's concurrency design when I was first trying to program in it. It's a lot simpler than I realized though. Like it's really only functionally dealing with two threads most of the time. You've got whatever thread the host application is running on, which is potentially the, I guess, the message loop that the UI toolkit you're running in. Anyway, that's usually like the main thread in the application. I guess this is a backwards way to explain it, because fundamentally I think what they're calling the message thread could actually be a variety of different threads. It's just there's basically one big mutex that protects their entire GUI subsystem. So it acts like they have one big GUI thread and one audio processing thread, even though in practice there's actually one audio processing thread and a variety of threads that all share one fairly heavyweight mutex. But then they also seem to be pretty commonly sticking mutexes inside of the packed-in data structures. So if you use like Juice's built-in array, it's got a optional mutex that it can just include. I don't know, it's like I don't really understand what use cases some of these features are trying to hit. I might just have to search the code base to see where they're used, if anywhere. And so this thing that's just a time slice client on the grain data itself probably wants to be something more like a thread pool job on an index loader. It might be simpler to do the UI side of this first. The documentation doesn't talk about this at all, but I think from reading the code, I want to verify this, but this is safe to call in any thread. Thread pools never change size while they're alive, do they? Yeah, okay, so that's constant while the thread pool object exists. It's also interesting that they're starting the threads in the constructor. Other parts of juice kind of go out of the way and make you start threads explicitly, and sometimes you don't want them to start as soon as they're allocated. Maybe I will use this pretty much the same way and just add the map image as a job. I don't know if it's worth allocating a whole separate job object. Right, like... So this is for regenerating images as I'm like resizing the window. I don't actually want to queue up all the intermediate sizes. I just want to wake up the thread and give it the opportunity to check for the latest size, because I have no use for all those intermediate sizes. I mean, they help a little bit, but that's really not what I want the thread spending its time on. This is also, I've got a couple of opportunities here in this code to clean it up by moving some stuff that's in the headers into the modules, like stuff that doesn't have to be public. This map image, I think this technically wants to be inside the map panel. I might not do this just yet, but I'm also thinking grain data might be split up into like a grain index and a grain waveform cache. Right now, grain data is just the index, and it's protected by one read-write lock, which seems like a pretty good strategy. It's often being read concurrently by the UI, and the audio thread changes infrequently. When it does change, I can just take a relatively heavyweight lock and then swap out a pointer and then delete the old one asynchronously. Beans. I think this is all stuff that like really wanted to be inside the map panel. I just I think I was assuming it had to be in the header if I wanted this map panel to have a complete definition. It doesn't actually need to have a complete definition outside the module though, because nobody else is allocating these. Is that true? That's not true. Other folks are allocating these. There's no like map panel factory. One pattern I noticed in the juice code base is that they'll have an internal implementation structure which is hidden, and then just include a standard unique pointer to that. Which seems pretty sensible. It's like an extra pointer to follow though. I don't know if anybody cares. This is conceptually sort of the image itself, but then sort of it's a renderer for the image. Wondering if maybe it makes sense to have like a renderer job class and just allocate one of those and stick it in the thread pool. That was one thing I was hoping Juice would have is more like cross-thread messaging techniques. I think they really rely on memory sharing for a lot of things, which is like, it's like fine for some cases, but sometimes you really do just want like a FIFO that you can send messages through. And I don't think there's a good version of that built into Juice. think what I'm going to do later for the higher performance thread pool is probably just start with stuff that's in the STL. So instead of grabbing a library for somebody's existing high performance, what am I even after? It's going to say single or multi-producer, single consumer. Is that what I'm after? This is actually where I think decided that I'm just not going to worry too much about trying to reduce data structure contention in this particular place, because I think fundamentally I do have a thing that I want to serialize. Like I want to have one place where I'm checking to see if there's already a request put out for this particular grain, and then like dispatching it to a thread if there isn't already a request for it. You can go without that and just deal with adding duplicate requests, but I think that these are expensive enough to compute that it's probably worth just having like a mutex protected data structure that keeps track of requests. So it's not quite the like extremely decoupled kind of solution some folks would go with, where you'd have a bunch of things happening in single producer, single consumer, like per thread queues for inputs and outputs that mostly don't talk to each other. That was something else I was thinking about doing. But duplicating effort on the processing threads is bad enough that I think in this case it makes sense to use a different design. Beans. Can you tell? Oh. I think the design I like is that so I probably rename this class like map image renderer or something and do my best to make it internal. Then I think instead of being a time slice client, this would be a subclass of thread pool job. But then I would have one instance of this that I keep around fairly persistently. And so instead of like piling up new thread pool jobs, I would just have one that I reschedule as necessary. think it makes sense for the juice value tree linkage stuff to be inside the component. So this stays here. I also really want to make room for the concept that this thing that I'm rendering is not the entirety of what goes in this UI component. It's just like a background image, because there's going to be dynamic stuff on top of it later. Now it's going to be confusing about whether we're rendering like in the background or we're rendering the background of the UI. It happens that it's both, but it is confusing. I'm not calling it the background renderer. Coming back around to plan A here with my original name, just maybe making it, you know, a private class instead of public like that. Just map image. I don't like that. Clearly, I should call it the cartographer. I might just call it image. Just rely on the namespace to give it context. Background would be better, right? Or maybe to use a word that means, or could mean something similar to background without being as confusing, it could be like the static portion. Static is also very overused in this language. I don't know if I have a good reason not to just put the thread pool in here as a public member. Man, naming is the hardest part of this project, or maybe all programming. There's ultimately going to be two thread pools that are both used for different kinds of background loading. I might call these general purpose threads. Oh, the rest of this needs a bunch of cleanup too. Nick, doesn't it give those classes access to private members in here if I namespace it this way? I don't really want that. I also don't know that it matters that much. There was, I don't know if that was a question, a comment about the programming language. It's C++. I guess no. I guess that is exactly what I want, because I do want image render to have access to layout, which is also private. Doesn't extremely matter that they can access these if they chose to. Just checking over whether this, how this behaves if you try to add a job to the queue that's already in the queue. I think it just lets you add another copy. Let's start with one general purpose thread, maybe. I think this needs to be public. Change broadcaster. What's that for? not a good way to like just add a job if it's not already in the queue. It's tempting to just always in-queue a job and have the worker function just disregard duplicate invocations. Where did I leave the juice? This isn't even going to be responsible for interacting with the thread pool, but I guess it will. I'm leaving the indentation at mask because I'm just going to run Clang format on this whole thing once it's in a slightly less broken state. It's kind of convenient. Guess we aren't going to save a reference to the audio processor here, so we might as well have image render actually save the thread pool. Let's see how close that is to going through Clang format without errors. Did the formatter actually like that? Oh yeah, we don't want to be using juice image anymore. Oh, I guess I did actually keep this separate. Fine. Okay. Mm-hmm. Guess I could just initialize that in the constructor. I don't have to keep it around. Where's the start? I was trying to have one of these shared UI thread or shared time slice threads just for UI stuff. But I convinced myself it's better to have a small thread pool that's shared between kind of non-performance critical parts of both the UI and the audio processor. Oh, thread pool jobs have to be named. Chica. At least the public header file is much simpler already. It almost compiles. That's actually useful. I didn't really mean to do a copy here, but that is actually what I'm asking it to do. Right, I was starting and stopping that manually, but thread pool just does everything in its constructor. And that no longer stores audio processor. Oh, the panel does need to access grain data here for doing mouse um, layout conversion, I guess. Seems like a thing that we're going to want to be able to do is while we're handling mouse events, look up data from the grain index. I guess I'll just have a pointer to the audio processor here. Oops. Compiles. Cool. So the thing we just did was moving the image creation here to a background thread, and those asserts are new. Yeah, what's that? Oh, we do have some asserts that catch jobs being added to the pool multiple times. I guess this assumes that whoever's calling this already has exclusive access to the job. I guess I just keep track of that separately myself. It doesn't really seem like thread pool jobs are intended to keep track on their own of whether or not they're added to a pool. Like they just have some asserts to that effect. It seems like they want you to already know whether it is or not. All right, there's no reason to use an atomic or anything fancy because we already have this mutex protecting data that's accessed at the same time. Just use regular Boolean. a deadlock between the internal lock in the thread pool and this mutex. Maybe. Oh, hey, Chico. Whoa, loud boy. Yawn. Yeah, I think in order to avoid a potential deadlock, I will be careful to decide whether we're adding the job under that lock, but not actually add it under that lock. Oh, hey, Chico. Okay, well, it rendered, and it rendered again, and so far no asserts. That's the UI thread doing its lookups. The resize jankiness is not new. Oh, I was noticing actually between streams that it resizes a lot better if I use the corner, so this might just be a bug in the window manager interaction. This looks fine. Let's just do a little printf debugging to kick the tires, but I think we're doing all right. Maybe I will go ahead and make this 2 threads. I think I wanted to be able to do a couple of things at once, but that's not my main thread pool. Right, like the interaction with the UI could be better, but I think the thread pool is doing its thing. Ooh. Oh. I guess I do actually need to wait for that job to finish and the destructor. Does this work by walking the array or checking the pointer in the job? Walking the array. Okay, they also don't document this, but it is possible to have a timeout that's negative to indicate there is no timeout, which is actually what I want here. The alternative would be to structure this so that we can let some memory leak if that job never finishes. Should we do it that way? I don't think it's currently safe to let these jobs leak because they have a reference back to the audio processor. Yeah, we just have to wait for that to finish. On the bright side, it seems to be safe to wait for our job to finish, even if it isn't necessarily running, which is good. I mean, it's convenient, but it's also kind of necessary. This is going to be waking up every 2 milliseconds and grabbing the lock that everybody in the thread pool is fighting over and then scanning the list of all outstanding jobs. But I'm going to hold my nose and use it because it's not performance critical. It's actually a bigger problem that I can potentially block shutdown until the job is finished, but it's kind of necessary in this design. What would happen previously? I think I noticed the same kind of failure mode previously when I was using the time slice thread. It just involved different, like a slightly different flavored crash, but that one still did, like also did not handle, like I think the time slice thread itself had like a 500 millisecond timeout, which is usually fine, but I think I did crash it once by having a really slow resize going while I tried to close the window. I don't know for sure, but that glitch just for a second looked like maybe the UI thread is blocked with a bunch of other resize related stuff that's not my fault. That's interesting. I think we just deadlocked trying to wait for the job to finish. It might be interesting to try again in a debugger, but did I do something obviously bad? Oh, I hadn't noticed that this has a listener. Is that useful? Is the listener not? Oh no, here it is. Thread listener. Yeah, that just seems to be for asynchronously canceling jobs. I don't think that's relevant to my needs. I don't say anything obviously bad. Let's try that with the debugger. Okay, a bunch of internal threads, 2 pool threads, and our main application thread. The main app thread is in the destructor waiting for the job to finish. Thread pool is waiting on the big juice message manager lock. Why is it doing that? Oh, we're doing that to send the change message. Yeah, that's dangerous. That's a recipe for a deadlock, and that's what we've got. Got the UI thread waiting on the thread pool, and the thread pool waiting on the UI thread. Let's see what else the message manager can do for us. Maybe there's a safer way to deliver change messages. Call function on message thread, maybe? Can I do that without acquiring the entire message lock? Right. Easy deadlock generator. There's a question about what this project is. It's a granular synthesizer kind of thing. Right, like what does Juice intend you to use to notify the message thread that something finished on your thread pool job? Hmm. How could this be correct? So it's like mostly fire and forget. We're allocating. I'm just looking at like a random example of how the thread pool job is used inside Juice itself. So they've got something for scanning audio units on iOS here. And it's creating a special thread pool just for this. It's creating a bunch of these jobs that all have a pointer to this in them. So these jobs have to finish before the, what is this class? AU scanner is destroyed. There's our scan job, really straightforward. What was the destructor doing? I think this can only work because we own the thread pool, and it might be fine in that case. If the thread pool does wait for completion. I mean, this might be just something we kind of treat as a special exit case and avoid this deadlock by, like, just avoid the deadlock specifically by trying to tell the job that we're trying to exit before we actually take that UI lock and try to exit, so that if it's trying to take the UI lock, it can first notice that we've set that flag. It's pretty bad, right? I want to look inside that message dispatcher a little bit. Is there, in fact, just a thread-safe way to fire off messages like this? Oh, did I miss call async, or is that undocumented? Ooh, I did miss call async. Can I do this safely? All right, send change messages on the listener. What's it? Change broadcaster. I could think that if there's a message queue, I could be using that directly to solve this problem. Like right now, I'm not really interacting with the message queue at that level. I'm just invoking UI callbacks here. Does this actually sound like a Windows message? A hidden message window. Wow. Okay, we're doing it that way. Okay, no thanks then. And how does this work on Mac and Linux? So it's like converting it into, what is this, a Cocoa event in OS 10? Oh, and on Linux it's a socket. So it's definitely intended to be thread safe. kind of messages can I send? Who's using this? Action messages. Keyboard events are like that. Oh wait, this isn't keyboard. What is this? I don't know where this is used inside juice. It's not multi-threaded C++ without a deadlock on exit, right? That just means we're doing it right. So the deadlock I'm hitting right now is send change message. I'm trying to take this message manager lock, but if we're closing the window, then we're in the middle of that UI event where you click the close box. So the message manager lock is already held there, and we're trying to wait for this thread to finish in that destructor. And so now we have these two threads waiting on each other. And of course, we don't need this result. This is kind of a classic problem where you have a background job that you no longer need anymore, but you don't have a safe way of stopping it or discarding the result. I'm wondering if I can move the message manager locking elsewhere, or even just completely change how I do the completion notifications here. This isn't even actually completion. This is just like we made some progress because there might be another render in the queue still. I mean, this is all we even want to do is just ask for a repaint, which is definitely something that we can just send through the Windows system. Can we make it this change listener's responsibility to deal with the locking? I think that actually works. I think we can do it that way. So inside image render itself, its destructor will still wait for the job to finish. Before this is invoked, right, that's owned here for the entire time. What is this image? Map panel. Yeah. So here we'll disconnect the listener, and then after this destructor runs, the destructor for image will run. So all I need to do is change the responsibility of who manages that message lock, and this should work. This certainly changes the thread safety properties of this message dispatcher. There's no extra lock taken here, so anytime this job is registered, you might get a callback on whatever thread with no particular lock held. I think that's actually fine. Okay. Very simple change, but had to think that one through. This would generally be a lot faster on a release build also, but it's easier to make sure the slowness is handled correctly in this case at least. Resizable windows. That is unrelated to what I'm trying to debug. Tall. This is an unrelated problem with Juice's multi-monitor support. Not gonna look good if the component has a 0 size. I mean, it's not gonna look good if you assert either, now will it? A bunch of comments like that in the source tree. type of programmer who is indignant about the inputs being incorrect and so just crashes despite the user. And for all I know, the window manager was setting it to 0 transiently, or maybe it was just so tall that it wrapped around. Anyway, let's try this without the debugger attached. Very slow renderer and debug. This is where it was deadlocking before. Still waiting for the image to render. Oh, and it doesn't deadlock. Cool. Let's try it a couple more times. Let's also make sure it's still reasonably fast on a release build, because this is extremely slow right now. If you ever want to make a random program crash, one of the things to try to do is just give it a bunch of work to do and then try to close it. Okay. That is all behaving as expected. Let's try... So the next thing I wanted to do is give this same treatment, kind of thread poolifying the index loader for grain data. And I might at the same time do some renaming so that that's actually called an index loader and I can separate the index and the waveform data. This might be a good stream stopping point in a sec, though, if I'm trying to keep the streams from being extremely long. I don't know why it's blank. It is broken. How did I break it? Let's do a clean debug build just to make sure that it wasn't the clean build causing problems. Tico. It's interesting. It sure looks like it wasn't even trying to render on the release build. Maybe we debug the release build and see what's going on. This cat is much more effective than the software. Cat just keeps on being a cat. He's doing great. That's our thread pool. I wonder if sorry, I had a theory that I immediately shot down. I was thinking that maybe it was not getting this initial update because maybe on the release build things initialized in a different order. But I wouldn't expect that to also break this when I pick a new file. And we're getting new information from the index. So this is pretty early on. We know what size the image should be, but I don't think we're going to have any data for it yet. That was the only invocation we got. Okay. Now we're getting another call. Is that a problem with this? Oh, am I not initializing as pending? That's probably the problem. I don't have this pointer. I can't easily look at that, but... Race initializers. I don't know if that was it. Well, it fixes the symptoms. And is way faster. That was probably just the only problem. Yeah, much faster rendering. Like the background renderer actually keeps up with the resizes better than Juice's foreground thread here. Oh, why do we have a spammer? Don't be a spammer. Yeah. I can't currently load the ones that are over 2 gigabytes because of other problems. Okay, I think I can remove that debug print and then check this in, and it will be an improvement. So we've got a little general purpose thread pool now in the audio processor. We no longer have a special thread for the audio processor editor. bunch of kind of namespace tidying inside the map panel. And moving that lock around so that we can avoid a deadlock. Cool. Okay, so that all had the effect of also giving us a much simpler public interface for map panel. Now it's just basically a UI component that you attach to the audio processor, and it does its thing independently. And the audio processor provides it a thread pool. And this module just needs another big pass-it refactoring. Right, I don't want this to have its own thread. Or rather, yeah, this just needs to be split up into at least an index and a waveform cache. Well, maybe I will do that on my own just to keep this stream relatively concise. Maybe we can hang out with Tuco for a minute and then I'll wrap things up. Beans. Stretch. I will see you folks on the next stream. I'm trying to do these about every other day at this point. Starting, I don't have like a set time, but usually like in the afternoon Pacific time. I will see everyone next time.